challenging GPU dominance when CPUs outperform for on-device LLM inference. Now, this one talks about the types of LLM systems that you can run given the number of tokens. So they run a token comparison because ultimately you're going to pay for tokens from GPU to CPU. So what they did was they used a 1 billion parameter LLM deployed via Llama CPP on the iPhone 15 Pro. We show that a CPU-only configuration, which is 2 threads and F16 precision, achieves 17 tokens per second, surpassing the 12.8 tokens per second obtained with GPU acceleration. We analyze the architectural factors driving this counterintuitive result, revealing that GPU memory transfer overhead and CPU thread optimization play a critical role. Now, what do you think I'm going to say about this? What do you think I'm going to say? Here's the problem. Well, it's not really a problem, but here are some of the findings. So the concept here is that the data transfer from the LLM to the GPU and back, or really even not that much because it kind of lives inside of the GPU, right? But the data transfer is hardware limited. And when you run certain things on the CPU, it can have hardware-based performance capabilities that you don't get out of a GPU. And so when you do a comparative when you do a comparison between the two, then you can have a CPU that outperforms a GPU. They do go into the, near the end here, let me find it. Yes, into the discussion here, they do go into some of the things that you could say work against their study. So they can't tell exactly why they got the results that they did. They've had to make some assumptions because they don't really know how CPUs and GPUs operate at a core level. That stuff is usually industry trade secrets. You can see in the limitations, some of the prompts that they're using, the ways that maybe mobile does performance enhancing stuff for mobile devices that maybe you don't get out of a desktop, the ability to properly profile things, the scope of the model because it wasn't like the largest model out there, the types of prompts that they use, power consumption. I mean, there's a lot that goes into why they got the results that they did. I am not making the case that this is some kind of, I don't know, I'm not bringing this up because like, haha, look at this, look at how dumb it is or anything like that. It's interesting. It's an interesting paper that highlights something that I think is very true. And that is, we don't even know how to use our own hardware properly in this day and age of the tech industry. In 2025, we have hardware that we barely actually understand, and what little we do understand about the hardware that we have, which is leap years ahead of anything we had even 10, 15 years ago, we don't use as efficiently as we could possibly be using it. We don't even understand what that looks like. And when you have an AI system, which is essentially just a bottled up package of all the bad code and bad decisions and hallucinations and all of that, but put that aside for a minute, when you have an AI model that can sometimes run more performant on a CPU than a GPU, that should raise some eyebrows about what else are we missing that could run more performantly on the hardware that we do have. What else could we be doing that we're not doing? Because clearly there's something that we're not firmly grasping here. So the paper in and of itself is an interesting one. It highlights some of the things we don't understand. It highlights some of the things we do understand. And it highlights the fact that I think generally speaking, when we're just writing or whatever code we're writing, many people in the tech industry don't have a good understanding of what the heck is going on under the hood. And then we just write whatever we write and we cater to, bad things. We're massively underutilizing the amount of power we have at our fingertips. It's crazy to me. So I thought that was an interesting one.